So let's turn now to what it takes to call a web service. In general, what we're looking at is a web service is going to live inside of the web application server, whatever you have going on there. It could be Tomcat or something simple like that, or it could be Glassfish, WebSphere, WebLogic, one of the more advanced ones. It doesn't really matter, because what's happening is the caller makes a SOAP request. That SOAP request is coming in over HTTP. It's just the same way it was coming over port 80 to come get a web page, but the content is going to be XML delivered inside of a SOAP request, and then the response back is going to be XML delivered inside of a SOAP response. Remember, HTTP is about text. It just happens to normally be HTML that's going back and forth. But there's nothing to say that we don't give it XML that instead of being HTML is going to be SOAP, going to be a WSDL, going to be the request that's coming in. So the great part about this is it's operating on port 80 or port 443, whichever way you've defined it, HTTP or HTTPS. So it's probably going to be open to most firewalls. It's going to be open to most networks. It's going to be a pretty easy way to tunnel in. I don't need special protocols, special servers. It just runs right next to the rest of my web application. And I don't require super secret code to get there. So I'm going to do either an HTTP GET or a POST, depending on what's going on. Most of the time a POST here, because we're doing web services. This actually is showing you a call to a special type of service called a REST service. So it's a URL inside of there. But the point being is I have some URL like this. Could be a GET call, or most likely it's going to be a POST call, in which case it's going to just some resource on the server and making a call to a servlet or some other tool that's going to be receiving that request. So when I make that request, I'm going to get a response back. We'll not talk about detailed request in. We'll see those as we go. But most likely we're going to get a response back with some more details inside of it. I'm probably going to get data back. Hey, show me all of the products you have for sale today. Now show me all of the T-shirts you have for sale today. Now show me the T-shirts that are blue you have today. That's the type of things I normally use web service calls for. Of course, I can do, I want to buy this now, I go pay this bill now, things like that. Those are just more detailed requests in, but you can see the XML that we're getting back comes in the structure of something that looks like data would be familiar with. In this case, we have a bunch of students, a list of students that's coming in. And so, we have this list of students here, and then here we have an individual student object which has a first name, a last name, a student ID, their gender, and a degree program. The gender here is 77, notice, because that's the character for male or female, M or F, that's coming along here. It's actually representing it as a number which gets converted back into a string in the way this was mapped over. It's actually automatically generated code here. This is not code that I wrote, and we'll actually see how this code can be generated. But it's pointing to specifically URLs inside of here, which point to the places where this stuff comes from. Now, as we talk about this calling of services, who can call a service? Well, obviously a Java program can. We're going to write Java programs can. But a .NET program too could too. As a Java user, I can call a .NET service, or as a .NET user, I can call a Java service. But more importantly, web browsers can call. It doesn't really matter. You just need the ability to do HTTP and parse the response. So mainframes can call web services as long as they have the ability to call HTTP and get a response back. The most common place you'll see services is within the browser environment these days. Not to say it's the only, or even the majority of the value. It's just a very common place for that to happen, because as we were talking about before, I use web services as a way to refresh part of a page without having to call and refresh the whole page. Why do I want to go get all the pictures and everything else when I want to lose the context of that page, when all I want to do is say, okay, I was looking at this listing of real estate, now show me the ones that only include 2-bedroom houses, or show me the ones that are less than $1,000 a month, or whatever it's going to be. So in that case, I use the browser's ability to execute JavaScript to be able to update and call and bind my web browser to different services in the back end. Now, there's a specific way this can happen through a technology called AJAX. Now, AJAX started off with this acronym, Asynchronous JavaScript and XML. It was the way that browsers could do stuff, if you will, behind the scenes, not refreshing the whole page, but as the page is still being there used by the user to make updates to the back end. AJAX these days doesn't mean asynchronous JavaScript and XML because A, it doesn't use XML, and B, it does a lot more than just calling in the back end. It does all sorts of display fancy stuff that is part of the JavaScript that happens. But it is a key technology that started basically with the idea of going back to servers and being able to go get data from servers and basically that interplay back and forth from information. Now, in order to do AJAX, I need a few players. Most likely, I'm going to use some sort of JavaScript library that's going to help me do this. And there's a few of them that are out there. So jQuery is probably the most popular these days. It was started off as an independent piece and was picked up and made part of the .NET network, which made it very popular. Dojo kind of had the same thing on the Java side. It's very tied to Java type development, but Java didn't have a ubiquitous platform. One that was great, and I think it's deprecated now, was the Yahoo UI library. That was a great one inside of there. But really, jQuery is probably the most extensive, at least at the time of recording that. Probably changes every week, but there's dozens, if not hundreds, of these frameworks that help you do that. These do much more than just call the backend. They allow you to really display data, put it in tables, dynamically move stuff on the screen. There's all sorts of capabilities, but what we care about is the ability to go and call a backend and update data. Now, when we say XML as part of JavaScript, it's perfectly reasonable to pull back XML and parse it as such. There's libraries, as we talked about, that'll help with that. If we have services out there that do it, then great. But JavaScript is a very dynamic language, and there's a much easier way to go and get data. There's this thing called JSON, the JavaScript Object Notation. Because you got to remember, JavaScript is a interpreted language. Java itself, I write the code, I run it through the compiler, and I create a class file. JavaScript, I take the code, I download the code from the server, and run it on the browser. I compile it and then run it all at once. So if I'm doing that, instead of creating these arbitrary ones and zeros or text or object representations, XML representation of objects, I can return to you source code that's just like me saying variable X is equal to new person passing parameters and so on. So JSON is essentially JavaScript that's passed from the server to the browser and then compiled real time and used to translate data instead of XML. So let's take a look at what some JSON would look like. This is the exact same response we saw before in XML, only in JSON. Now, it's much tougher to read, but it's much more condensed as well, because every time you see the curly brackets, it's the same as saying there's a big list of things coming up. And then, I'm sorry, an object there. Every time you see the square brackets, there's a list of things coming up. Every curly brackets is an object. And so instead of having to say this is now a student object, curly brackets, there's a list of student objects. And there's some students inside there, which is the square brackets. And then the curly bracket's a new object. And you look through that, there's a URI, then there's a degree program, a first name, a gender, a last name, a student ID. And then you can see that now there's a bunch of students shown in the same amount of space that I was showing you, one or two, which was nicer formatted, admittedly, but you can see we can compact them very nicely. And this is not exactly human readable, but it's not impossible to read. If you separate it out, you can see how the pieces go back and forth. So this is the key to being a caller. Whatever you're going to be, you have to formulate an XML request. Or, as we're going to see in a minute, in REST, just formulate a GET request. Don't even have to generate an XML request. I ship that to the server. The server does some magic on that, and it gives me back a response. That response is going to come back as either XML or JSON, most typically. It's going to be a text response back. And then my application can either parse the XML or execute the JSON, and I get data back. There are libraries that I can request JSON and get, from Java. I can go request JSON and turn that back into Java as well. I can parse this into whatever I want to. But the idea is this is all provided for you in some library. It's going to make it happen. So this is the protocol, but you probably won't have to deal with the details of this so much as here's a call, go make the call, and come back with it. So that's calling. That's the role of the caller. So services are really dynamic and open up a whole new world where now in my Java code I can go ask for data from someplace else with very low overhead and no need to build sockets and interfaces and parse text and all that sort of stuff. Just simply, hey, go call this and get it back.